how we can find. So last was page number 11, 12, 13 now. 13. Okay, great. Page number 13. Right with me. Unit number 4. Vector differentiation. Okay, below this radar, it consists of one directional derivative, second vector identities, third irrotational. Those who want to prepare for the GATE exam or any technical exam in civil engineering, this topic is very important. Huh? Irrotational vector field. Solenoidal vector field. And last, tangent and normal to given curve. Okay. Next radar. Right. Engineering mathematics by H.K. Das. Vertical. Krasik. Erwin Krasik. Krasik spelling, I think some letter is remaining. K-R-Y. Krasik. Okay. Then done. NPTEL lectures by जितेंद्र कुमार. देखते हैं थोड़ा सा. 1 minute only. ये है allow videos to play. System of linear equation यहाँ से है. Vectors little bit. It is in engineering mathematics 1. It is in engineering mathematics 2. I think it is not saved here, right? Jitendra Kumar. Engineering maths 2 course. Hope this is clear. YouTube video. You can go through the YouTube videos. Then next, course outcome. For that, we'll go through the COPO mapping. C 202.4 perform. So student should able to perform vector, write with me, differentiation and integration, analyze vector fields, and apply to fluid flow problem. BT level 4. What is BT level 4? BT level 1, remember. BT level 2, understand. BT level 3, apply. BT level 4, analyze. And therefore we have this word here. Analyze. Okay. Then mapping. Here it is. Right. C202.4 mapped with PO1 at the level 3, PO2 at the level 3 only, PO9 at the level 1, PO10 at the level 1, and PO12 at the level 1. This is the mapping. Hope all these things are clear. Okay, let me start with the few definitions on the next page. Yes, change the page. Page number 14. I am audible?
Yes, sir.
Okay. Start. Page number 14. Right. Scalar point function. So till we are considering scalar as a some number. Now we want to consider a function, scalar function we want to consider. Huh? So right. If a scalar quantity means a quantity having magnitude only. Scalar quantity phi depends for its values on its position x, y, z, then phi of x, y, z is known as scalar point function. For example, phi equal to x square plus y square plus z square. One more notation, psi. X square y minus y square z plus zx. These are the scalar point functions. Okay. Next, Radha. Vector point function. Right. If a vector quantity, now fast. If a vector quantity f bar is there for the vector, depends for its values on its position x, y, z. Then f bar of x, y, z is known as, for example, g bar. And vector point function. Next. Level surface. Right. Consider a scalar point function x, y, z. 5 x, y, z has same value in level surface. Any example known to you of level surface? अरे कोई एग्जाम्पल पता है क्या आपको लेवल सरफेस का? डू यू नो एनी एग्जाम्पल ऑफ लेवल सरफेस? अच्छा चलो ठीक है, ये ऐसा कुछ पढ़ा है आपने?
आजच शिकलो.
काय म्हणे त्याला?
इंजिनिअरिंग जिओलॉजी मध्ये.
हाँ क्या बोलते हैं उसको?
हे एक प्रकारची जीप आहे ना. हा आता जो तुम्ही काढलाय तो हिल आहे. हिल.
हाँ कंटूर्स.
हा काउंटर. हा काउंटर.
काउंटर नहीं कंटूर्स म्हणतात त्याला. ओके देन
टूर.
ऐसे कुछ पढ़ा है आपने? थोड़ा सा ट्राई करता हूँ, see whether this is correct. ज्यादा ही हो गया. हाँ इंडिया जैसा लग रहा है शायद, है ना? अरे बहुत ही बेकार आ गया. ठीक है, यू कंसिडर दैट इट इज इंडिया. हाँ And then on 10th June, this is 10th June line. This is 5th June line. Okay.
वेव्ह
Wave कसले?
विंड
This
विंड
is say 25th of May. And here, this is around 10 September. Yes, anyone? क्या है ये? कैसे लाइन से? और कुछ जिंदगी में पढ़ा है या नहीं?
करंट विंड ना
कसला करंट?
ट्रॉपिक ऑफ कैंसर।
नहीं ना, अरे ऐसा रहता है थोड़ी ट्रॉपिक कैंसर। 10 जून का और ट्रॉपिक कैंसर का क्या मतलब है? अरे मान्सून कब आता है उसके लाइन से?
सर वेगवेगळ्या प्रकारचं असतं मॉन्सूनचं असतं वेगवेगळं असतं
पण ह्या डेट्स मान्सूनच्या आहेत. इन पुणे द मान्सून कम्स ऑन 7th of June. This is for the Mumbai. This is for where the Maharashtra starts, say Kolhapur. This is for Kerala. This is for Rajasthan. Right? Monsoon onset time. Or when the monsoon arrive. Okay, these are the this line. This is a level surface, right? This contour is one of the level surface. Everywhere on this contour, the height is 100 meter. If you take the innermost contour, the height is 300 meter everywhere. I think you know all these things very well. So they are known as the level surfaces. Okay, no problem. Let me continue. As a civil engineering student, these contours and level surfaces are very important for you. Okay, next definition. Let me change the page. Dale or Nebula operator. It is a vector. It is vector differential. So both the things are there. It is vector as well as it is derivative also. Vector differential operator denoted by del, or just write del in this, and given by I del by del x, j del by del y, plus k del by del z. Right? This is the Nebula operator. What is this? Remember, vector quantity. From where we understood that it is vector quantity, it contains ijk. Okay, now understand what we want to do for the whole topic. एम क्या है हमारा? Aim to study properties of. Now we want to operate del on a scalar. Del is a vector. Dot is not written as, though you have to understand that del is a vector. So vector operated on scalar. Should we write dot between them? दोनों के बीच में डॉट लिखना है या क्रॉस लिखना है? कौन सा करेक्ट है? डेल डॉट फाई इज करेक्ट या डेल क्रॉस फाई इज करेक्ट? कौन सा करेक्ट है?
डेल क्रॉस फाई।
हाँ, एनीवन एल्स? अरे डेल वेक्टर है, पाई स्केलर है. कैन वी राइट डॉट बिटवीन वेक्टर एंड स्केलर? डॉट किसके बीच में लिखना होता है? Studied it in previous lecture. So this is absolutely wrong. This is absolutely wrong. याद रखना है आपको. Dot cannot be written between a scalar and vector. तो सिर्फ कैसे लिखना है? फॉर एग्जाम्पल अल्फा इज अ स्केलर एंड ए बार इज अ वेक्टर, तो कैसे लिखना है? ऐसे लिखना है, कुछ नहीं लिखना है, डोंट राइट डॉट एंड क्रॉस, सो इतना ही लिखना है। और इसका रिजल्टेंट क्या रहेगा? वेक्टर। और इसको बोलते क्या है? ग्रेडियंट ऑफ फाई। आ गया समझ में? ओके। नाउ डेल वेक्टर है एंड एफ बार इज आल्सो वेक्टर, दो वेक्टर है। बताओ आप क्या लिखना है दोनों के बीच में? डॉट लिखना है, क्रॉस लिखना है, या ऐसे ही छोड़ देना है? ए बोला कि रे यार, काय नावाने कधी घेत बसू रे? तुमचं तुम्हाला कळते की नाही? काय बोलत नाही, काय नाही. प्रीतम, प्रीतम आहे की गेलं सोडून? हा, काय
Yes,
लिहायचं
sir.
प्रीतम सांग. डॉट लिहायचं का क्रॉस लिहायचं? दोघांच्या मध्ये एक आहे तसं ठेवायचं.
Sir, screen
काय
show
करायचे
करा.
स्क्रीन? दोन वेक्टर आहेत. डेल इज अ वेक्टर, एफ बार इज अ वेक्टर. व्हॉट इज टू बी रिटन बिटवीन देम? धनश्री सांगा काय करायचं? व्हॉट इज टू बी डन? कुछ पढ़ते नहीं. शुभम क्या करना है? डॉट लिखना है या क्रॉस लिखना है? शुभम, आर यू देयर?
येस सर.
हाँ, काय करायचं? डॉट की क्रॉस? अरे राजा, दोन वेक्टर असले, सपोज ए बार एंड बी बार इज वेक्टर, कैसे लिखते हैं? कौन सा सही है बताओ आप?
सर
जस्ट राइटिंग ए बार बी बार इज करेक्ट, राइटिंग ए बार डॉट बी बार इज करेक्ट, और राइटिंग ए बार क्रॉस बी बार इज करेक्ट. कौन सा करेक्ट है इसमें से?
सर ए बार डॉट बी बार.
हाँ, दिस इज रॉन्ग. एंड ए बार क्रॉस बी बार चलेगा ना, कोई प्रॉब्लम नहीं. ओनली डिफरेंस क्या आएगा? विल बी वेक्टर. Okay, so if I write del f bar, that is wrong, but I can write dot between them, or I can write cross between them. If I write dot, it is a scalar. If I write cross, it is a vector. Right? जब डॉट लिखते हैं तब स्केलर आता है, उसको बोलते हैं डाइवर्जेंस ऑफ एफ बार. इसको बोलते हैं कर्ल ऑफ एफ बार. इन तीनों के प्रॉपर्टीज हमें पढ़ने हैं और कुछ नहीं करना है. आवर एम इज टू स्टडी प्रॉपर्टीज ऑफ दीज थ्री. आ रहा है सबको समझ में? तो पहले से स्टार्ट करते हैं. स्टार्ट विद द फर्स्ट वन. ओके, चलो समझो थोड़ा सा कि क्या हम कर रहे हैं एग्जैक्टली. हाँ, तो मजा आएगा, नहीं तो फिर देन इट विल बी वेरी बोरिंग. ओके, स्टार्ट. These are the different ways to write it. Gradient of, right? When a vector differential operator del is operated on scalar point function phi of x, y, z. Resultant is a vector quantity known as gradient of phi and given by grad phi or del phi, and that is equal to बेटा डेल हमें पता है क्या होता है. डेल I del by del x plus j del by del y operated on phi of x, y, z. So it is very important to remember that it is a vector quantity. आ गया इतना सब समझ में? चलो थोड़ा सा आगे बढ़ते हैं. थोड़े से we want to understand few concepts of geometry and then we'll start with the examples. हाँ? चलो लिखते हैं आगे. Change the page. We studied all these things in the M2. हाँ, 3-dimensional geometry ना वहाँ पे पढ़ा था हमने. Hope you remember. Say we have x axis over here, y axis here, z axis here. Okay, ये origin है. And then we have a point P of x, y, z. Okay, इसको join करते हैं. Angle made by the line OP with the x axis alpha. Angle made by line with y axis beta. Angle with the z axis gamma. Then alpha, beta, gamma are known as angles made by the line with x, y, z axis. And cos alpha, cos beta, cos gamma are known as direction cosine. Start. If alpha, beta, gamma are angles made by line with x, y, z axis, then cos alpha, cos beta, cos gamma are known as direction cosines. Are known as direction cosines. Okay, right? Here L square plus M square plus N square equal to, anyone remember? 1. For example, direction cosines of L1, 1 upon root 3, 1 upon root 3, 1 upon root 3. इसको आप चेक कर सकते हो, L square plus M square plus N square 1 है या नहीं. Okay, right. Second, one upon root 2, 0 minus 1 upon root 2. Okay, then another second. Direction ratios. The three numbers proportional to LMN are known as direction ratios. For example, drs of L1, ये है ना L1, whose direction cosines are 1 upon root 3, 1 upon root 3, 1 upon root 3. उसके direction ratios हमें find करने. So what is to be done? Hope you remember we studied this in M3. You multiply three numbers by any non-zero number. Okay, so say I multiplied by 2, so 2 by root 3, 2 by root 3, 2 by root 3. Or okay, so direction ratios are not unique. Say I multiplied by 10 root 3. Okay, so I'll get 10, 10, 10. Suppose I multiplied by minus 5. So minus 5 by root 3. These are direction ratios. Okay.
root 2.
Hmm?
One.
क्या मतलब?
डायरेक्शन रेशियो सिम्पलेस्ट रेशियोज असतात ना.
नाही, असं काय गरज नाही. It is better to take the simplest ratio, but again it is not compulsory. Again it is ratio, na? Say I say 1 by 2 is the ratio. Then I say that 5 by 10 is the ratio. So it is okay. There is no any problem. Okay? Then data. Relation. What is L? Hope you know all these relations. Right? This is the relation. Okay. Then write down note. Direction cosines are unique. But direction ratios are not unique. Direction ratios of equally inclined line are 1, 1, 1. Someone may say that it is 10, 10, 10. Correct? Someone may say that minus 17, minus 17, minus 17. Correct? But better to consider 1, 1, 1. Right, equation of straight line. Line passing through x1, y1, z1 and x2, y2, z2. Yes, anyone remember how to write this? याद है ना? So next. x minus x1 by a, y minus y1 by b, z minus z1 by c. Next on. Right, comparing about two equations. Direction ratios of a line passing through the point x1, y1, z1 and x2, y2, z2 is x2 minus x1, y2 minus y1 and z2 minus z1. Then if A, B, C are DRs of a line, then direction of line in vector form is next. If 1 minute, huh? Give me 1 minute only. Right, next. Normal to a surface. Suppose phi of x, y, z equal to c is equation of surface. They is how to find normal? Grad phi. Grad phi, you remember, na? Grad phi is normal to the surface. Next, Radha. Next page. Right? Suppose This is equation of surface. This is tangent to the curve. Next point. Directional derivative. Okay. Sure. See towards board and understand. See, I have one level surface over here. Phi equal to C. I am making small change in phi and then I am finding one more level surface. Another level surface. Phi equal to C and phi plus delta phi equal to C are the two level surfaces. Okay. Then I am taking a point over here. Okay. Then from point O, I'll join it to the level surface to meet the level surface at the point P. Similarly, I'll take a point Q on the next level surface and I'll join it. Okay. Then this is P. Then I'll join this. These are the different vectors. OP bar is denoted by R bar. So OQ will be R bar plus delta R bar. Okay, yeah. Draw it and then write. Draw the diagram and then write.
मोबाइल से ईयरफोन है
Consider two level surfaces. Phi and delta phi equal to C.
हॅलो सर.
Uh-huh.
P.5 इज इक्वल टू सी मध्ये सी वरती पास होतो का?
P point.
फाय इज इक्वल टू सी वरती पास होतो.
हाँ हाँ. Point P दिसत नाही काय तसं? हाँ. असं आहे.
पॉइंट
आता
पी.
ते point P ना?
पी.
C कुठला पॉइंट आला रे?
पॅरटचा पी.
C कशाचा?
फाय इज इक्वल टू सी वरती पॉइंट पी पास होतो ना.
हो हो हो. Absolutely. लिहितोय ना आता. Write this. P is a point on level surface phi equal to C and Q is a point on level surface phi plus delta phi equal to C. ये क्या झेपते कि नहीं? फॉर एग्जाम्पल ये जो आप समझ रहे हो ना लेवल सरफेस से, ये टेम्परेचर है. हाँ, से टेम्परेचर T equal to 30 degree Celsius here. और उसमें थोड़ा सा चेंज कीजिए. हाँ, सो से टेम्परेचर T इक्वल टू 35 डिग्री सेल्सियस हियर. ओके, सो जो पहला लेवल सरफेस है, ऑन दैट वी कंसिडर्ड अ पॉइंट P. On the second level surface, we consider the point Q. Right? Now understand next part. Now read up. Now our aim is to find rate of change of temperature along PQ bar, known as directional derivative. समझ रहे ना मैं क्या बोल रहा हूँ? Rate of change of temperature along PQ bar, along A bar. Okay, that is known as directional derivative. Okay, Srana. Rate of change of phi along PQ bar, that is A bar, is known as DD, directional derivative, and it is given by this is the formula, grad phi dot A cap. Now tell me where the directional derivative will be maximum. Now आप थोड़ा सा समझ लीजिए कि whenever we are finding along A bar, तो क्या कर रहे हैं हम, टेम्परेचर लिख रहे हैं न्यूमरेटर में, एंड डिवाइडेड बाय हम लेंथ ले रहे हैं, है ना, लेंथ. सो व्हेन द लेंथ विल बी मिनिमम, ये जो लेंथ बोल रहे हैं ना हम ए बार, वो मिनिमम कब रहेगी, यहां पे रहेगी मिनिमम. यहां पे यानी कहां पे, whenever there is the two surfaces are perpendicular to each other. Perpendicular means in terms of vector it is normal. Okay, so right. Directional derivative is maximum along normal to the surface phi equal to C. That is, what is normal? That is along grad phi. Grad phi is the normal, na? So directional derivative is maximum along grad phi. What is magnitude? Right. Third, magnitude of maximum directional derivative is mod of grad phi. That's it. Okay, so तीन फॉर्मूले आपको याद रखना. What is directional derivative? Grad phi dot A cap. Where it is maximum? Along the normal, that is along grad phi. What is its magnitude? Mod of grad phi. Okay, I will go through few examples. Let on find. Chalo. Okay, let me change the page. Right, examples on directional derivative. Directional derivative along a straight line. Right. First example, find directional derivative of 4x z cube minus 3x at 2 minus 1 2 2 minus 1 2 in the direction of 2i plus 3j plus 6k. Towards the point along equally inclined line. Solution. Right. Directional derivative of phi equal to c along a bar is. What is the formula? Grad phi dot a cap. Okay. Now here right now. So you might have understood phi is a function of x, y, z. So ordinary derivative does not exist. So we have to take partial derivative. Na? You remember, na? Number of independent variables are 3. So partial derivative. Find derivative with respect to x. With respect to y. With respect to z. Right. Therefore, grad phi equal to so getting. Now where we want to find directional derivative? At this point now. So in above vector, substitute x equal to 2, y equal to minus 1 and z equal to 2. Chalo, substitute karo. X equal to 2, so 2 cube is 8. 8 into 32. Minus 6x is 2, y is 1, z is 1. Minus 6 into x square, 24, minus 24, minus 48. X is 2, z is 2.
तर 48 च्या जागेवर 24 येणार ना.
पुढे
48 32
अच्छा.
minus 20 32
x y square हाँ संचोक 24 करो
32 plus 24
हाँ.
ना.
के का
हा सॉरी वाय स्क्वेअर आहे बरोबर.
Are you able to find this? 8i plus 48j plus 84k. Chalo, next page. First part is to find directional derivative along 2i minus 3j plus 6k. So, mod of a bar. Unit vector. So it is so grad phi. What was the grad phi? Seven is scalar, huh? So I can write it outside. And I hope you remember how the dot product is obtained. I component together, J component together, K component together. Use calcium, tell me what the answer is. चलो कॅल्सी यूज करा आणि सांगा मला आन्सर काय ते. Yes, what the answer is?
पॉइंट मध्ये चालतंय.
नाही नाही फ्रॅक्शन पाहिजे. येते कसं? B part homework, C part homework. Please do it yourself. Okay, we'll continue after Diwali. After Diwali, we'll continue. Huh? Happy Diwali to everyone.
Happy Diwali, sir.
Same to you, sir.
Okay. Yes, thank you. Chalo, bye bye. You can leave.